Thank you. Last day, we were looking at collisions, and we said that in a collision, or in an explosion, which we'll do another lesson on, but in a jeune, momentum is conserved. We said the law of conservation of momentum says that the amount of momentum you start with has to be the amount of momentum you end with. Diego, there's various ways to write it. I'm a nerd and lazy, so I said the shortest way that I know how to write it is that. The total momentum to begin with equals the total momentum you end with. But also we remember that momentum is what times what, mass times velocity. So we started looking at some collisions here. These were kind of little comic strip panels. Next lesson, we'll just turn those into word problems. But it's, again, going to be find object A, find the mass of object A, what's the mass of object B, how fast are they going? Read the question. If you see words like east and west, Sarah, make sure you let one way be positive and one way be negative. Okay. So we did a couple of questions. Let's do C and we'll do D. Now, in your homework, if you want to take shortcuts because you're getting good at it, go ahead. On a quiz or a test, be really, really meticulous. Let's do this one like we were doing our homework. So I would say, Riley, first of all, what are they asking me to find from way back when? You know what? What's got a question mark next to it? VA initial. Is there a collision? This is a job for conservation of momentum. Okay? I usually write this down. The sum of the momentum that we start with equals the sum of the momentum that we finish with. I will give you a half mark for writing that down on a collision question because you've learned enough physics now. Emily, this tells me you know what approach to use. Riley, before the collision, what's moving? Car A, car B, both or neither? Before. Stuck together or separate before the collision?
Separate.
By the way, I notice after the collision they're going to be stuck together, so we'll have to figure out how to deal with that. So before the collision, they're both moving. They both have momentum. Momentum is what times what? It's on your green sheet. No panicking. Go look. Yes. So the momentum of car A, I'm going to say is mass A, velocity A, initial, and that's what we're eventually going to get by itself. And momentum of car B is mass of car B, velocity of car B, initial. If you wanted to, Riley, you could put a little negative right there just so you don't miss it, because it's going to be negative. Wham! They collide. After the collision, Riley, what's moving? Car A, car B, both stuck together or separate? Any thoughts on how I can write stuck together? Ready? Stuck together, same velocity. Must be going the same velocity because they're stuck together. There you go. What are we trying to find, right? I guess the whole right side is going to drop down like a domino. What else, kiddo? What else will I do to get the VA by itself? How will I move the MA over? Okay. How will I move the MB, VB initial over? Which one am I going to do first? Yeah, reverse bad mass. So minus, good. And then what, Riley? Divide by? There you go. Mr. Dewitt, can I start sticking numbers in earlier? I'm not going to mark it wrong if you do, but I really think it's worth getting good at the algebra. You can see, I think, how things fit together better than you can if you've replaced everything with numbers. Oh, and Riley, I'm going to put the VA initial over here on the left because that's where we're used to seeing it. And I think we're at the numbers stage. VA initial equals, Riley, what was M1? What was M2? I'm going to be brave and just add those together, M1 plus M2 in my head, 6,000. I think I can do that. What was V final?
5.
And double check, positive or negative? Is it positive? Okay. Good habit to check your signs. And then minus, what was VB? 4,000?
Yes.
Sorry, what was MB? I said VB. What was MB? 4,000? And what's VB? Negative 3? All over, and MA was 2,000. Okay. So here's some of the physics that, say, the RCMP can use to reconstruct car accidents, right? Can I do that one in my head, Mr. Duke? Yeah, it's going to be 30,000 plus 12,000, 42,000. 21? No. Yes? Is that right? Pause. Am I wrong? Oh, maybe I'm wrong. Check your negatives. Check to make sure you put the top in brackets. Positive or negative? What do we get? So car A was coming in really fast. Car B was going backwards, not very fast. Wham, they collided, stuck together, and car A and B moved off, continuing forward. Car A slowed down, car B sped up. That works. Okay, that's a legitimate collision. Brackets. Last one. I'm old. I'm 52. When I was a kid riding our bikes, one of the things we liked to do, we had a nice flat field. It was a school field. We would ride our bike on the school field on the grass, jump off, run alongside of it, and then try and jump back on again. We called it ghost riding. I don't know if you guys still do such a thing. Oh, we all play video games now. Shut up. Okay. Anyways, some ghost riding, jumping off. Let's make some predictions here. Is this a collision? No. But what this technically is, since they're splitting apart, it's an explosion. And I said to you, Sadie, conservation of momentum works when there's a jeune. We can use conservation of momentum here. We really, really can. But I want you to notice what's happening here. Joanna, the rider, after they jump off, did they slow down or speed up? I'm going to ask you the same question. I'm just going to phrase it differently. Did they gain momentum or lose momentum? So what must the bike have done? If the rider lost momentum, what must the bike have done? Gained, right? Because momentum must be conserved. So is the bike going to speed up or slow down if it gained momentum? This answer here better be bigger than 5. You can start to make some predictions looking, Declan, for like calculator errors or things like it. You can kind of, wait a minute, if momentum is conserved and one object slowed down, the other object had to have sped up. Had to have. That's as long as they're in the same direction. It's trickier when you have negatives in an opposite direction. You really got to think about it. But you can make some predictions. Okay. So, is this a collision? Technically not. Is this an explosion? A slow one. But yes, an explosion is just stuff flying apart. The bike and rider flew apart. So this is a job for conservation of momentum. It looks like they want me to use R for rider and B for bike. I'm good with that. Joanna, before the collision, what's moving? The rider, the bike, both or neither? Stuck together or separate? I guess that's going to look like mass rider and mass bike stuck together. Wow! The biker jumps off. After the explosion, what's moving? The rider, the bike, both or neither? Stuck together or separate? So we're going to have mass of the rider, velocity of the rider, mass of the bike, velocity of the bike, and it looks like we're trying to find that. Hey, Joanna, get the VB by itself. What's our next equation going to be? Yep. Yep. Okay. And then I'm going to put the VB over here on the left because that's where we're used to seeing it by itself. In your homework, if you were, I'm going to try going straight to my calculator now. I'm okay with that in your homework. On a test or a quiz, I would absolutely write out the numbers, so we'll do that in our notes. I've scrolled down. Joanna, what was the mass of the rider? Mass of the bike? V initial? And then minus 60 V rider final? All divided by 20. I know the bike's going to speed up. I better get an answer bigger than 5 because the rider lost momentum. The bike had to gain it. 60 plus 20 is 80 times 5 is 160 minus 120. 160 minus 120 is 40. No, I'm doing something wonky. Hang on, Mr. No, it's 400 minus 100. Wow, bad math. 400 minus 120, which is 300 minus 20, which is 280 divided by 14? 14. Whew, wow, almost made a silly mistake there. What's your homework? Number 1 is good. 2 is good. 3 is good. The answers for question 3 appear on the next page because for some reason I just couldn't fit it on there. Okay. You can skip 4. 5 is good. Now here is a word problem that you'll have to translate. So we have Calvin, we have Hobbes, we have the mass of Calvin, we have the mass of Hobbes. Make sure if they're in opposite directions, you let one way be positive, one way be negative. If they're in the same direction, you can let them both be positive. Number 6 is also worth doing.